Hello, my name is Patrick Ford and I'm a media developer and makerspace manager in the CIDL at Anderson University. One thing I love about makerspaces is the pedagogy that underpins it. While problem-based learning, or PBL as we'll call it, is nothing new, it's enjoyed a resurgence of sorts through the maker movement. PBL can inform teaching and learning no matter what our resources may be. One of the most profound experiences I had with problem-based learning was also one of the simplest. In high school, my shop teacher gave us 2 slips of paper and 4 pieces of tape, and asked us to support as many books as we could with them. We set to work solving this, quote, problem, creating shapes from paper stood up on its edge until finally, my team discovered through existing knowledge about bridges that cylinders support weight the best. We supported 8 books with cylinders. Our teacher said, "Good, but is 8 all you can do?" We knew we needed more cylinders to support more weight, but we only had 2 slips of paper to build with. So I said, "What about a figure 8 design?" After we had stacked 10 books, we knew we were onto something. 22 books was all the paper could take, and our teacher debriefed us on what was one of the most effective and engaging lessons I had ever seen. All problem-based and with nothing but paper and Scotch tape. The beauty of this approach is that the possibilities are virtually limitless in instructional design. I mentioned earlier that problem-based learning is nothing new. Even though the term was popularized in the 60s, it's as old as time itself. Think about all of the problems we have solutions for that someone had to find, like transportation, antibiotics, or the math of the triangle. Now think about the solutions we need for today's problems. They'll be solved using the same method, problem-based learning. It's easy to see how this type of learning occurs in the real world, but more difficult to foster it in a classroom. PBL fits into a learning theory called constructivism, in which the learners construct new knowledge along the way. The end goal, i.e. the solution, is usually clearly defined, but the path to get there is not. Many students struggle with this new freedom, and many faculty find it difficult to measure. PBL allows for greater student voice and vision, personal connection with the problem, opportunities for collaboration and competition, consistent and imminent feedback for the learners, less lecturing, capitalizing on learner motivators such as recognition, and holistic, interdisciplinary, and self-directed learning. Some of the limitations are that PBL can be difficult to assess and measure, too time-consuming for the class and teacher, overwhelming for certain students, or difficult to match to certain standards. Don't let the limitations discourage you, since most of these can be overcome with a little practice and forethought. A starting point for this can be thinking about Bloom's taxonomy. At the bottom we have remembering, which implies that students must have background knowledge before they can begin to solve a problem. Once learners have that knowledge, they move up Bloom's taxonomy until finally they create something. In this case, the solution to a problem. With PBL, the steps of this process happen almost in tandem. Let me illustrate this with a ridiculously cheesy meme. Remember the Play-Doh extruder? Think of the extruder as the problem itself, acting as the driver for learning. The Play-Doh inside is Bloom's taxonomy, all compacted into one small space. Once the pressure of time and need is applied, new solutions are created. It's an iterative process, so you can always ball it up and start over again, or use that new knowledge as a stepping stone to another problem. We learn quite well this way. Think of the saying, "I did it by watching a YouTube video." Why is YouTube such an effective teaching tool? Because you're motivated by a problem or question, you gain knowledge from YouTube, you gain feedback by immediately trying what you just watched, and are able to self-assess your own work to solve the problem. This is why makerspaces are such valuable assets to a classroom or school. In addition to teaching the intended content, PBL and makerspaces can also teach ancillary goals like teamwork, time management, and digital literacy and determination. Skills like critical thinking and design thinking are the hardest to develop in students, but are natural byproducts of PBL. PBL is concerned more about the mindset than about a physical space or expensive machines. Resources like Legos, craft supplies, or a video camera can often be just as effective in instilling the maker mindset in your students. Instilling this in your students can be done through many different ways, but here are a few just to get you thinking. Model the determination you want to see in your students. Students who see their teacher give up at the first sign of trouble are not likely to espouse the grit needed for problem solving. Don't teach, facilitate by being a guide that eliminates hand-holding and gives students ownership. Embrace failure and experimentation. Students who feel understood are more apt to try again and with more vigor than others. The key to making PBL work is having authentic problems for students to solve. It ensures they gain knowledge and confidence to tackle new projects later on. Because what's the point of asking for solutions if there's no problem to solve? As an extreme example of what problem-based learning is capable of, let's look at a program at James Madison University called X-Labs. X-Labs is a group of courses that have no tests, no textbooks, and no right answers. Students are asked to solve massive problems like homelessness and left to self-direction, guided only by weekly visits to their facilitators, who typically only ask more questions. They must research, collaborate, and innovate in ways that push them to their limit. In retrospect, alumni describe it as the hardest, most rewarding thing they've ever done, saying it prepared them with confidence, skills, and knowledge for the future. X-Lab's authentic real-world problems ensured that students were able to engage in high-order thinking, which prepared them for more complex problems in their future career. Through student voice, teacher guidance, and motivating problems, students are empowered to create solutions. We looked at how to leverage the maker mindset to make any space a makerspace where PBL can thrive, and finally, we examined a real-life example of PBL in action and the lasting benefits students can gain from it. Problem-based learning can be time-consuming and resource-hungry, but it's also rewarding. It's not for the faint of heart, but it's most definitely worth it. I would encourage you to start by modifying one project or assignment by adding a problem that needs solving. Don't try to change too much at once and overwhelm yourself. Again, the key is to make it authentic to real life and let your students do the work. Thank you for watching, and I hope this Pecha Kucha was helpful to you. If you enjoyed this video, please feel free to share it. Also, feel free to find me on Twitter. I'd love for you to teach me something. I'll also point you to our university department website at aucidl.com. Thanks for watching.